So hello everyone, welcome to BISP Solutions. In this video, we are going to see uh, introduction to tensors, and we'll understand what tensors are, and and we will see what all operations we do on the tensors. So let's move ahead and let's understand what is tensor. So tensors are multidimensional arrays that forms a foundation of deep learning. Let's visualize them from scalar to multidimensional tensors. They generalize scalar. So uh, below you can see the image of a tensor scalar, which sorry, 0D tensor, which is a scalar, and it is just a number. Then comes the vectors, which is 1D tensor. Then either it can be in a row or a column. Uh, then matrix, which is 2D tensor. You can say 2D array. Then there is a multi-dimensional or high-dimensional tensor, which is 3D or ND, you can say. Okay, so these are all the like these are the tensors which are used in uh, PyTorch, and these are basically the foundation of deep learning. So you have to be thorough about this. Let's move ahead and let me take you to the Spider IDE so we can see the operations on tensors and what are the interoperability with the NumPy. So, so this is our Spider screen. So very first thing you need to do is you need to install the torch. So what you will do, you will go to your console and use type pip install torch PyTorch. Oh, okay. Install PyTorch. So this will install the PyTorch onto your PyTorch library onto your IDE. The next thing, okay, so it is throwing some. Okay, so I have already downloaded it. So then what you want to do is if you want to create your tensors, you need to import the library for Torch. You need to import Torch library. Then uh, let me take a variable which is t1 and let's create a tensor. So for that, you call your library torch.tensors and let's create a scalar. So this is just a number, so which will be a scalar. Okay, let's print this uh, tensor. So what I'm going to do, okay. So this is a tensor, and let's check the type of this tensor. For that, you actually need to do is t1 dot t type, and okay, so type, and let me click on enter. Okay, so the type of this tensor is integer. So what if I add a dot after 4? Now let's check what. Uh, so now our result has been changed from integer to a float 32. So 4 dot is a representation for, let me write it over here. 4 dot is a representation of 4.0, which is a float. Okay, now let's uh, let's create a vector type of tensor. So I'll create a variable which is t2 and torch dot tensor. Same method here we are going to take, and let's add a matrix. Okay, and let's just print the uh, tensor. So here you can see our tensor is a vector which we have created a 1D vector. This is a 1D, sorry, 1D tensor. Then let's create a 2D tensor. For that, what we do, let me take a variable t3 and then tensor. Okay, so let me add 1, 2, 3, and then let me add another row. Oh, dot C, and t3. Let me, okay, so this is our 2D tensor. Okay, now suppose if I add a float value onto any value in this tensor. So I'll add in onto the one, I'll add a dot. That will become our float value. And let's now print the output. Okay, let's now print the output. It has automatically changed uh, all the values to float. So this is done automatically by the by PyTorch. Okay, so this is your this is your 2D tensor. Now let's create a 3D tensor, which will be so torch dot tensor, and inside this we will add two more brackets. So this is going to be a 3D. Let me add the same. Okay, so mm, this will be the 4, 5, 6, and if we come out of this will be our secondary, sorry, second matrix. So 6, 7, 8, 9, and then 10, 11, and 12. Okay, so let me bring it down. So here you see at the outer you see three brackets, which for your understanding, you can say this is for the 3D array. Inside that we have defined two matrices. So for one, this is our complete one matrix, and then our second matrix. Uh, so this will be from here. Okay, let's just run this. Mm, mm, okay, for this, we actually need. Mhm. Inside this bracket, there is two. We separate it from here. For this, we have to. Okay, let me run this again, and we then print our output. So let's just print our output. So this is here you can see our you can say 3D tensors, which is uh, uh, matrix behind matrix. So this will be a first matrix. Behind that, this is going to be a second matrix. Now, these are actually, if you want to see the shape of your tensors, you can do is you can say t4 dot shape. It will tell you. Uh, okay, so this is going to tell you. So inside first array, sorry, yeah, inside first array there are two uh, elements, which is your this is your first element, and then this is your second element. Okay, then inside second bracket you have again two elements, this one and this one, and after that in the last bracket you have three elements. So this is how your this shape is telling you the elements inside each brackets. It is specifying from the outer till inside. Okay, so this is uh, how we how the shape is doing. Now let's move and see tensors, operation, operations, and gradients. Okay, how tensors and tensor operations and gradients are related. So let me create three tensors. Okay, so first let's create an X tensor, for which torch.tensor, and inside that let me provide a value. Then w torch.tensor and 4 point, then required grad is equal to true. We will discuss what this required grad means for now. Let's just add that torch.tensor and 5 point and required grad is equal to true. Okay, so these are three tensors we have created uh, onto our for the further operations. Let's just print these tensors. Okay. Hmm, required grad is equal to true. Let me remove this. Let me check where we are getting the error is in this line. So let me remove that and let's see if we are still getting the error. Okay, now this comes on the second line. Okay, uh, let me add again requires grad. It is actually requires grad. True. And again, now let's just run this. Okay, so we are getting our output. Now let's create a new tensor y by combining these tensors. And for that, we are going to create a arithmetic operation. Let's do some arithmetic operations on y. So this is y and w multiplied by x plus b. This is the arithmetic op- operations we are going to perform on these tensors. Let's print y and let's see what output we are getting. Okay, so it has provided us let me print this okay, so this line you see over here, it has provided us the multiplication of these. If you do like say uh, 4 multiplied by 3 is 12 plus 5 is 17. So it has provided us the arithmetic operations on the tensors. Let's now what makes PyTorch unique is that we can automatically compute derivatives of with respect to tensors. So we can actually the request grad is used for finding out the derivative. Okay, so if we do the request grad is set to true, then w and okay, so this will give us the derivatives for w and b with respect to y. This features of PyTorch is called as autograd, which means automatic gradient. So to compute the derivatives, we can invoke the dot backward methods on our result y. So let's compute, let's compute derivatives. Uh, so for that, we will do y dot backward and let's just print our display our uh, display our gradients. Okay, let's print all the x, w, and b gradients. Let's see what results we are getting. So first one is wy by wx. Let's print this. Uh, print wy by dw, and this dot grad is short for gradient, which is another term for derivatives. Okay. Uh, Let me print w dot grad, and the final one is wy by wb and b dot grad. Let's print and let's see what output we are getting. Uh, okay, so the first dy by dx, you can see it is showing none, because we have not added our parameter, which is requires grad. So it has not calculated the derivatives with respect to y. Then for the other two variables, which is w and b, uh, it has provided us the gradients. So in deep learning, whenever we take a derivative, most of the time we take derivative with vector or matrix, so that is why we call it gradient. Okay. Now let's see interoperability with NumPy. So NumPy is a popular open source library used for mathematical and scientific computing in Python. It enables efficient operation on large multi-dimensional array and has a vast ecosystem of supporting libraries, including Pandas, Matplotlib, OpenCV for image and video processing. So, okay, so now let me import NumPy as well onto our code. So import NumPy as as np, and let's see how we can create an array in NumPy. So if you have idea about the NumPy, you already know how we can create. Let's see. Uh, so array, we use a function array from the NumPy library, and inside that we provide our uh, array. So we are going to create 2D array. So 3 and 4. Let's print this and let's see what output we are getting. So hey, you can see the difference between the NumPy array and the tensors is when we were printing the tensors, it was telling that this is a tensor, and when we are creating an array with the NumPy library, it is telling us that it is a array. Now let's convert a NumPy to a tensor torch or torch tensor, sorry. So let's take a variable y, and I'm going to do is numpy sorry, torch dot. Then there is a uh, method which is from numpy. Okay, this is a method which will convert a numpy array to your tensor. So what you are going to do is simply you are going to provide the variable where the numpy array is stored. So I have done that. Now let's just print the y variable. Okay, so uh, let me print this also. Print x. Okay, okay, it is not telling that it is an array. Okay, no worries. We are seeing over here that from the array, numpy array, it has converted uh, our numpy array to tensor. So this is how we convert do the interoperability on with NumPy. And uh, the let's verify the type. So what I'm going to do is let's print the type for both the NumPy array and the Y. Okay, let's do that. And here you can see this is the integer. Both are actually the integer since we have converted from the numpy array to the tensor. Both are int, but on the second here you can see is it says torch dot int, which means it has converted into the tensor. The next last thing is how we can convert from a tensor to a numpy. So first what we did is we converted from uh, numpy to tensor. Now we will see how we can convert tensor to numpy. Okay, so let me take another variable which will be z, and let's now take a variable take our tensor variable. I'll add dot, and simply we have to write numpy. That's it. Uh, this will convert your tensor into a numpy. Now let's just print and let's see the output for this. You can see again we have uh, converted our tensor to a numpy. So that's all about tensor. We will further discuss more about tensors in our future videos. Next, we are going to see about the linear regression and how we can work with the linear regression on PyTorch. So this is all for this video. Thank you for watching the session. We'll meet in the next session. Thank you.